So in this video we're going to discuss power, and the definition of power is the rate at which work is done, or the rate at which energy is transferred. So remember that work and transfer of energy are the same. Now, whenever you see the rate at which something is done, that is going to be that over time. So power, the equation for power is work over time or change in energy over time. And so the unit is joules over seconds, which we call a watt. So here we see lots of different variations of this equation. So we see power, which is written with the letter P, is work over time. Now it could also be energy over time as well, and any kind of energy we could calculate. But remember also that work is force times distance. So we could also see force times distance over time. And if you see here d over t, we know d over t is velocity, so it can also be calculated by taking force times velocity. So all different ways in which we can calculate power, but every unit is the same. It's always watts or joules over seconds. So let's just look at a couple of examples. So in this example, it says a cart is pushed with a force of 100 newtons for 10 meters in 30 seconds. How much power does it take? So remember, we have all these different variations of the equation, and really we just wanted to, in this case, do work over time. So work, remember, is force times distance. So we've got the force, 100 newtons, times 10 for the distance, so 100 times 10, and then over the time it takes to do that, so over 30 seconds, so we get that the power is actually 33.3 watts. Right? Let's do one more. So in the previous video where we looked at kinetic energy, I talked about a truck accelerating from 8 meters per second to 12 meters per second. But in this case, we say that it takes 5 seconds for it to do that. And I want to know, instead this time, not what is the change in energy or the work done, but how much power is needed. So if you remember when we did this calculation, we got work was equal to change in kinetic energy, and it was 6 times 10 to the 4th joules. And if you don't remember that, just go back and you can rewatch that video. Right? So if we exerted 60,000 joules in energy over 5 seconds, then we just take 60,000 and divide it by 5, and so I get that 12,000 watts of power were needed to accelerate that truck.